All right, without further ado, thank you so much for joining us, everyone online and here in the room. We're about to get started with the One Health Academy for September. Welcome back from our break. This is Blair Budd, and I have the pleasure to introduce our speaker for this evening, Dr. David Rigby, presenting the roles of water in the fate and transport of diseases and contaminants. David Rigby is an internationally recognized expert in the fields of water and wastewater engineering, water resource management, industrial wastewater treatment, and environmental resources sustainability. His entire career has been dedicated to protecting the environment through innovation. With nearly 50 years of experience as an engineer, business owner, and entrepreneur, Dr. Rigby has demonstrated a broad level of expertise in engineering, conservation, environmental issues, and business development. Dr. Rigby is a member of the environmental engineering faculty at the George Washington University and has taught both graduate and undergraduate level environmental engineering courses for more than 20 years. Please join me in welcoming Dr. David Rigby.
Thank you. Great. Thank you, Blair. It's an honor to be here, and I will take a little bit of editorial liberty as we start to kind of give the background of why or how I came to become a speaker. And I've been interested in the One Health Academy program for a number of years because it was held for a long time at the Capitol Yacht Club. And I sat in on many of those, and then when it moved here to the American Society of Microbiology, that headquarters, I attended a number here, and it occurred to me when I looked up on the website, it had the environmental health, the human health, and the animal health, and all the presentations that I had attended, they seemed to be focused on zoonosis and animal diseases, and maybe they would be transferred to the human side, but there was never really anything that talked about the environmental aspect of One Health. And I talked to Blair about that, and I said, well, you know, I don't really know that much about the animal and the human side, but my environmental side is where I come from. And so
just share the screen, so keep talking. They're just not seeing your screen. Don't let me interrupt you. Great. Sorry, guys. Thank you.
Oh, okay. Good.
You're on.
So
they heard you. They just couldn't see that.
All right. So anyway, as we talked about it, she said, well, it'd be nice if you came and talked about your experience in the water field. And I was also encouraged by Dr. Nichols, who deserves a lot of credit for this presentation. She provided technical critique and editorial contributions, and actually probably about half the slides in there are hers and not mine. And I'm wondering, why didn't she give this as opposed to me? But anyway, so we're moving forward. That was the editorial liberty I wanted to take. And let's see. How do I advance this?
Just arrow down.
Okay.
Yeah, you can.
All right, there we go.
Okay.
Good. So as I was preparing for this, I said, okay, well, what's an academy? Because I know that I remember having to send my son off to military academy because he was acting up. And so I looked it up, and it said it's the Society of Distinguished Scholars and Scientists. And I went, had minute, that's not me. I'm a sanitary engineer. I'm not distinguished nor a scientist. So I had some trepidation, but got started. As I mentioned, Tanya was kind enough to give me some support in this, and she actually provided this slide. And you can see that you've got the environmental health, the human health, and the animal health all working together. And so I wanted to speak about the environmental health. Now, sanitary engineering, I'm a sanitary engineer. And I guess in the broadest sense, I sort of work with water and wastewater infrastructure. And my academic background covered all of these topics: water treatment, wastewater treatment, public health, biochemistry, groundwater, fluid mechanics, that kind of thing. So broad background, probably a jack of all trades, but a master of none. And then as I found out about 3 weeks ago when I was down in Houston visiting my grandsons, that they had learned that I work with poop water. So you can imagine the jokes and the laughs that we had at the dinner table where Papa works with poop water. So work with water and with poop water. Now, the presentation is very broad brush. It's very high level view of the aspects of water and wastewater as it reflects and works with One Health. And I will talk about water, and I'll talk about poop water, and I'll talk about some other things. And each one of these slides that you'll see in this deck could almost be a presentation to itself. So like I say, it's very broad brush, but to give you all some thoughts on the role of water in the fate and transport of bacteria, disease, and contamination. One of the things that here again is another slide that Tanya helped me with. One of the early circumstances in One Health that dealt with the environment and dealt with contamination and water was the John Snow and the Broad Street pump station. And this was in London, and it was in 1854, and people were becoming sick and dying of cholera. And there was a lot of study on it, but nobody seemed to come to where the source of the contamination was. John Snow believed it was coming out of the public well that was in the square. And he pled his case to the town officials and to the government officials who did nothing about it. So he broke the handle off the well. And when he broke the handle off the well, then people couldn't use that well, and then the cholera epidemic stopped. So what had occurred was the groundwater in the well had been contaminated. My guess would be with poop water, and then the citizens were drinking it, becoming very ill. I will also talk about a number of anecdotal experience that I've had in my career. One of them was very similar to the Broad Street pump station. In 1975, we were studying a community called Falls Mills Hale Bottom in Tazewell County, Virginia. And at the time, EPA had grant funds available for construction of new infrastructure, particularly for new sewage collection systems. And if you could demonstrate that there was a health hazard within the community, you could get additional grant funds. So we did a blanketed the community, took samples of all the private wells, and then recorded that, and were able to present that and get some additional funding for the project. Because in particular, there was one house that, and we were streaking out the water on the auger plates and incubating them, and immediately it just basically turned green from coliforms. What we discovered was that the effluent from the septic tank was being pumped into the well, and the family was drinking septic tank effluent. And speaking with the wife, the mother, she said her baby was 6 months old and had been sick ever since it was born. And every time her husband went out to work in the yard with a glass of cold water, he would come back and be sick in bed for 2 days. So we didn't have to look all the way back to 1854 to find a similar problem. Interesting here again, Tanya provided this slide. And one of the things I want to point out, if I can get it up on the screen, you see there's two different lenses of water shown on this private well scenario. And the well drops down through one of the water zones into a lower water zone. Those water zones are called aquifers. And the water under the ground, groundwater, resides in a series of aquifers almost anywhere in the world. And they'll be at different depths, and the water quality and the water quantity will be different in each aquifer. Maybe you only have to go 50 feet to find water. Sometimes it's 1,000 feet, but it's usually laid in lenses, and there's usually, as you can see in the brown line between the two, that's called an aquitard, and that prevents the water from the aquifer above and below from mixing with themselves. So the idea in a private well is to find the better water source and tap that, and that's the water you pull to drink. What's interesting in the United States, and we wouldn't think this, particularly in DC, because we get most of our water out of the tap, is 70% of all the water consumed in the United States comes from groundwater. If you think about that, we take that water out, we use it, we flush it down the commodes. It either goes to a septic tank drain field, or it goes to a stream or a sewage treatment plant, and then it ultimately ends up in the ocean, and it's been filling up the ocean for eons. And it's why the ocean, and it's the primary, that with sediment erosion is a lot of the reason why the ocean level rises about 4 feet a century, because we're filling up the bathtub. And I'm going to come back to that, to this, or reference this here in a little bit. This this slide I patched in today. I read an article, it was actually published yesterday. EPA published it, and two folks from EPA, and it was in American Water Works Opflow Journal, and came out yesterday. And it talks about one of the problems that we have to be concerned about from contamination and disease is our public water supplies and our public piping systems. And we would think that, okay, we're getting the water out of the tap, it's nice and clean, we don't have things to worry about. Yet, if those pipes are old and begin to deteriorate, the deterioration of the materials within the pipe, or materials that maybe have accumulated on the sides of the pipe over the years, begin to slough off, and then they'll transfer contaminants and disease, particularly the corrosion byproducts. You get biofilms will be built up. Chlorine doesn't kill everything that's in the water, so you get microbial growth that gets released, and just the water gets old. So anyway, this was just recently published. So we have to realize that while we believe our water supplies, our public water supplies are safe, that depending on the age of the system, we've got to be concerned about diseases and contamination. I have to give Tanya credit for this one. This was her slide too. And in the news is, and it's a hot button, big issue at EPA right now, are the per and polyfluoroalkyl substances. That when we think about those, what are they? And they're like fire, flame retardants, and a number of things of chemicals, but they have definite toxicity within the environment, and they're very difficult to capture and remove, to treat and remove. And it's been recognized that they're completely in our water cycle now. They're in surface waters, they're in our drinking water, they're on the ground, they get washed off when it rains back into the streams. And as a matter of fact, just moments before I walked in, it was published that EPA has taken some additional action on PFAS in the news today. So, well, this isn't a disease, it's a contaminant that's within the system. I don't know if they're carcinogenic or just toxic, but there can be found in all manners of water supplies and water systems and lakes and streams. Now, to kind of make the whole water, wastewater arena or whatever more confusing, has been a national initiative in the past 5 years to take a look at all of the water that we use in the United States, no matter what the source may be, and consider it one water, and that we don't just take water and use it once and throw it away, that we try to conserve it. Maybe we reuse it for a secondary purpose. And now it's getting to the point where not only are they thinking about reusing it, waters that maybe have had certain levels of contamination, but to take that water and actually put it directly into a potable supply. So you've got a wastewater or a storm water that's been treated, or an industrial waste, and you say, okay, we're going to try to clean that up and we're going to put it into the drinking water supply. There's been a lot of pushback on that, but there's also been quite an initiative to say, yeah, but it's a resource we haven't really protected and conserved. Los Angeles and the state of California have recently gone through, in the last decade, a severe drought, and they were running short of water. Fortunately, their aquifers and their lakes and streams are full now, but they went 7 years needing more water than they could produce and store and deliver. And they sort of led the way in the last decade on trying to come up with a plan to develop a reuse program and to be able to conserve the water. And this is their plan for 2040, a lot of the elements of the plan. And they talk about, they start with stakeholder engagement. And that's really where it starts when you start with some sort of a new policy like this, or a new idea that says, hey, I'm going to take poop water and treat it so I can drink it. They looked at their existing strategies. They looked at reuse of wastewater effluent. Stormwater carries a lot of toxics and heavy metals and petroleum oils in it. So how clean or how practical can you clean that up to take it to a level of reuse? And anyway, the items are listed here. I'm not going to dwell on those, but they look at the risk of climate and resilience assessments, future strategies, etc. Wastewater treatment plants. They receive the domestic flow, domestic sewage from homes and from institutions, and commercial establishments, and all the raw sewage comes in, and then the wastewater treatment plants receive that, process it, try to make it clean, and typically discharge it to the nearby stream. And the graphic here, it says here's the homes, the industry, the office. First thing that happens is it goes through a bar screen, takes out the big trash. Then the little trash, or the things that settle out, go into a grit tank and it drops out. And that would be stuff like ground up bone or pieces of grit or even metal filings that might have gotten into the waste stream. That goes to a settling tank called a primary clarifier. The typical method of treatment, almost universally globally, is an aerobic system, microbial system where you've got activated sludge. The bacteria do the majority of the work at the wastewater plant to remove the organics and the solids. They go to a clarifier. The bugs, as they're commonly referred to, settle out in the clarifier, and then they get returned to the head of the process to eat again. And there's always waste sludge or waste bugs that are produced, because as those bugs are eating the organics that come through, they create additional bugs. And so those additional bugs have to be removed from the system, and they go to a digester, and then they become sludge. And we've heard about, we've all probably have some thought about what sludge may or may not be. Then the effluent from the clarification process gets disinfected, and then it gets turned into a receiving stream. In the lower part of the graphic, you can see the digester, and it shows you're putting some sludge into a truck, and the options for sludge disposal are incineration, put it on agricultural land and plow it into the fields, or take it to the landfill and bury it. And those are pretty much the three common ways that the additional microbes that have been removed from the system and digested are disposed of. So let me go back a second. So you see that where up there by number 4, where the upward arrow goes toward the receiving water. Well, thinking about the One Health plan, the one plan, One Water plan that Los Angeles had, if you took the water there as opposed to putting it into the stream and said, no, wait a minute, we're going to try to reuse this water, what do we need to be concerned about? And there's a lot of things to be concerned about, but EPA recently, just in February, came out with a treatment plant effluent action plan for reuse of, to consider the reuse of wastewater plant effluent. And the key elements of their water reuse action plan are validating the technological improvements, review the regulatory and policies at all levels of government, including public health considerations, financial initiatives. None of this comes without cost. And every alternative has a different capital cost and operating cost. Performance requirements. In other words, how can we be assured that we can always produce a safe quality of water that can be reused all the time? And then access to the water and to the data and the watershed, and then outreach opportunities, basically stakeholder engagement. One of the things that we don't seem to, that we probably don't immediately come to mind, and these used to be called endocrine disrupting compounds, and they've been renamed pharmaceuticals and personal care products. And what they are is they're pharmaceuticals, antibiotics, antifungals, insecticides, hormones, contraceptives, plasticizers, cosmetics. Even caffeine is considered a pharmaceutical and personal care product. And I'm proud of this slide particularly because I don't know that I've ever sat in a PowerPoint presentation where the speaker put up a slide that had a table that was so small you couldn't read it and you couldn't gain anything out of it. So I said, I have to put one of those in my presentation. But to take the pharmaceuticals and personal care products a step further, and you look just at the estrogenetic influence of the water that comes out of a wastewater treatment plant. And actually, I think that was first, the problems with estrogen in the effluent of wastewater treatment plants was first recognized here in the Potomac River about 20 years ago. Downstream of the Blue Plain wastewater treatment plant, and fishermen were beginning to catch fish that had both female and male sexes in them, sex organs, and they had disrupted endocrine systems, and they had these lesions and sort of referred to us. One article referred to them as Frankenfish. So it's very well documented that in the vicinity of a wastewater treatment plant, that the fish that are very close by can often exhibit these kinds of problems and these kinds of effects from the estrogen, at least, that passes through the wastewater treatment plant and gets into the stream. So if you think about us as humans, and we're going to go to take potable reuse of effluent, what is that going to do to us, and how healthy is it? And are we really there yet? Does the EPA reuse action plan protect us looking forward? In addition to putting water in the streams, effluent, and actually I've even seen a lot of instances where raw sewage or sewage that's just partially treated is used for crop irrigation. Now, if you think about crop irrigation, certainly if you've got fertilizer, additional water, those crops are going to be, higher producers. And so it's there's always the wish to be able to take water that's got high phosphorus and high nitrogen content and additional water and use it to irrigate crops, because the crops turn green and they grow like weeds, and you get higher yields. The problem is, not only do they have toxic contaminants in them, heavy metals in particular, but they also will take up in various, either in the fruits or the roots or the leaves, depending, various diseases, E. coli. We all have seen where lettuce and strawberries and things that have been irrigated with raw sewage have come into the United States, and then there's health outbreaks. The sludge itself, a lot of it, I said earlier, goes to grasslands and is plowed into fields and sometimes to croplands. This is a case, and I don't know this case personally, but it was one that was about 10 years ago, where wastewater sludge was being applied to a field, and I believe it was in Georgia, and the sewage sludge was, and the toxins within the manure toxins, which came from the sludge and pathogens, were deemed to be responsible for the death of a number of the dairy cattle that this farmer had. That's the only incident that I'm aware of that was the case, but the sludge itself has a tendency to concentrate toxins. If we're distributing or discharging the liquid, we may have very low concentrations of toxicity, but once they've taken the waste sludge out, digested it, concentrated it, dried it, further concentrated it, and then taken it out, what the process does is it further concentrates all those contaminants and all that bacteria. This is an anecdotal situation that I had that I experienced. We had done some work in western part of Virginia for Carolina turkeys, and they had a plant outside of Harrisonburg, Virginia, and then we were doing some upgrade at one of their wastewater plants, and then the director of engineering says, we've got a plant down in North Carolina we'd like to come down and take a look at. So we went down, took a look at it, and it's kind of a satellite image here, but the up in the top of the screen, that white area is that's the big industrial complex where the turkeys would come in and they'd be slaughtered and processed, and then the two fields in the back, the darker green here and then the green here, what they did was they had an on-site wastewater treatment plant, and they would take the effluent, because there was no local stream right nearby, and they would spray it on the fields. There's a lot of sandy soil there. And so in talking with the engineer and talking with the plant operators, I said, what are you doing with your, what's the status of your wastewater system? How good are you getting the treatment? At what levels are you treating? They said, we're nitrifying the wastewater, which meant they were converting the ammonia to nitrates. And I said, and then where's it going? They said, well, we're spraying it out in this field. And I said, well, how close by are the neighbors? And they said, why do you ask? I said, well, if you're putting all that nitrate into the groundwater and there's private wells nearby, they're going to be pulling out water from the wells that are high in nitrate, and you're going to have to worry about nitrosis and essentially blue babies, if they, the blue baby syndrome. And they went, so they went up and down the road that's there sort of to the right, sampled the private wells, and found that they were all excessively high in nitrates, way above the Safe Drinking Water Act allowable limits. And they ended up having to build a public water line to come out from the town and basically gave everybody public water, because they had contaminated the groundwater through the system. Agricultural runoff. It's kind of covered some of it. There's a number of factors that affect this. I believe this is another Dr. Nichols slide, and very nice one. And but the thing about agricultural runoff, you know, the fields are always worked. You're putting sludge on it. You're putting water on it. You're putting fertilizers on it. You're spreading manure on it. And so even if this hasn't been treated with wastewater plant effluent, it's going to have a lot of contaminants with it, a lot of bacteria, a lot of say nutrient contaminants, and it'll have pesticides, pathogens, etc. So one of the things in the United States, well, I guess worldwide, is that if you're downstream of an agricultural process area, the surface waters are usually fairly highly degraded. We've seen that, measured that in my over the years personally, but they're pretty bad actors when it comes to environmental pollution. In the news, and I saw one just last week in Florida, that runoff from agricultural fields that might be high in nutrients are causing severe algal blooms in a lot of our nation's waters. The picture on the left was Lake Erie. Just last month, there was a picture up in New Jersey. You can see the green algae in the water. That one of the problems with that, besides the fact that it's unsightly, is as that algae dies, it saps the oxygen from the water as it decomposes. Then the water itself will go sort of septic, and then the water becomes almost unusable for any purpose. So in trying to tie this together with animals and people and the environment, this just was back in July. Up in Wisconsin, they had a number of people get sick that were swimming in a lake. I don't know how much algae was in it, but there was a lot of beach partiers. I can't say they were defecating in the water, but they certainly were playing around in the water. There was a lot of geese along the beach and a lot of geese in the field, and the combination of the geese and the geese poop and the partiers, and a number of people got sick up there. And so that was kind of a combination of the environment and the animals and the people. I've got some personal affiliation with this one. One of the bad actors, microbes in this region, it's a microbe called Vibiovulnificus, and it can cause gastroenteritis. But if it gets into the body, then they say that it's about a 20% mortality rate if it actually gets into your body as opposed to just into your GI tract. And it's prevalent here in the Chesapeake Bay region. Anne Arundel County, Maryland, just in July, had to issue health advisory warnings and tell people don't go in the water, particularly around the Bay Bridge. There were a number of there was a lot of rain, I guess, at one point, washed in contaminants from the surface water, but also the Vibrio was known to be present in and around that area. It's a shellfishing area, and it's been known to, like say, kill people if they contract a disease. Now, I have personal experience with that because 2 years ago, I was asked to help at the Capitol Yacht Club shuck some clams. And on the very first clam, I ran the knife in, the clam shell fractured, and the knife went into my hand. And what I didn't know at the time, I mean, I knew I had punctured my hand, but I didn't think about it. Until 4 hours later, my arm was red and starting to swell up, and it actually had punctured a tendon, and the Vibiovulnificus had gotten inside the sheath of the tendon. I was taken to GW Hospital, spent better part of the night there on IVs. I had 2 weeks of strong antibiotics. When it was over, I said, great, I'm done with that. And 2 or 3 days later, I basically collapsed and they put me back in the hospital for another 2 weeks of antibiotics. So Vibrio is a bad actor. Now I think what you're probably going to begin to understand is sometimes maybe I should have my head examined, but I was in the Amazon a few years ago, did a river cruise. There were areas where there was a lot of trash. There was we saw a lot of the botos, which are the pink freshwater dolphin, one of 5 species in the world. And as they age, their skin becomes more translucent, so you can see the blood in their capillaries through the skin. Well, I had been fishing for piranha, and I'd been catching piranha on just raw beef and catching the heck out of these little guys. And I thought, it's my birthday. I'm in the Amazon. I'm catching piranha. I'd heard the stories about how if you get into the water, they'll take down a cow and eat it in 5 minutes and this kind of stuff. When I heard that when I was young, I said, well, I'm going to swim with them. So I jumped off the boat into the school of piranha, and they didn't bite me. And but I managed to swallow too much Amazon river water. And for the next 2 years, I fought an upset GI tract and went to the docs countless times. I was diagnosed with celiac sprue, which tropical disease specialist said, no, it's probably tropical sprue. But nonetheless, it was a couple years of dealing with that. Getting kind of close to the end, we did some industrial work. I did some work for an industry down in, or for Fairfax County, down in their Lorton section of the county, and we ended up being the expert witness for the county, for Krispy Kreme donuts, and for the developer that had built the system. And the sewer system had become contaminated and then had deteriorated to the point that raw industrial sewage was leaking out on the ground and dripping and flowing into the river. And so we looked at the Krispy Kreme industrial wastewater characteristics: high temperature, real high concentration of oils and grease from the frying of the donuts, a lot of sugar going down. The sewer pipe environment was anaerobic, and when I went to do the investigation, I had the Fairfax County engineers with me, and I said, we need to get a sample and see how much alkalinity is in here. And they said, what do you need to know that for? And I said, well, because in an anaerobic fermentation process, if you don't have enough alkalinity to balance out against the production of the organic acids, you'll have organic acids that will drive the pH down, and you'll have serious problems with corrosion. What we found out was the pH in the system was between 3.8 and 4.5, ate up the entire ductile iron system. They had to replace a mile of pipe and a pump station and a bridge crossing. These are just some pictures. The first picture on the upper right, they first discovered it when white stuff started getting pumped up out of the ground. And that was greasy wastewater from the Krispy Kreme. The pipes in the lower right all had holes in them, and the water was just being forced up through the ground, through the holes and through the ground. Lower middle, that shows one of the pipes, a big gaping hole in it. That was right as it was crossing the river. And then the other 3 are pictures of how we had installed the pipe in the first place that ended up being deteriorated by the acid. Other things that we should think about when we're thinking about contaminants and we're thinking about toxicity is a term called biomagnification or bioamplification of a toxic contaminant. And this was another one that I had firsthand knowledge of. A client we had was taking phosphate rock from Florida, grinding it up. Well, that phosphate rock had uranium in it, and it was just natural. And they were taking that ground up phosphate rock, adding sulfuric acid to produce phosphoric acid and gypsum. And the phosphoric acid was neutralized with calcium hydroxide, and which became dicalcium phosphate. Dicalcium phosphate was being used as an additive for the chicken feed to feed to the chickens, because it was a big poultry processor. And I said, look, let's check the uranium concentrations in the rock and in the gypsum and the dicalcium phosphate and in the chicken feed. And in every case, the concentration of uranium got a little bit higher and a little bit higher. And I said, well, now what do you think the concentration of uranium is in the chickens that you're feeding to the public? And at that point, I was released from my contract. A similar situation in biomagnification occurred, and this was back in the 80s, at the Cistern National Wildlife Refuge. And the Central Valley there in California was becoming more and more productive, and they needed more and more water. So the state constructed a canal channel from the north end that ran all the way along down the mountain and then dropped into the San Joaquin Valley, and then started to flow back to the north. So it started at the north, came to the south, and then once it dropped into the valley, it sort of worked its way toward the north. Well, what that water from the Sacramento River was doing is it was leaching selenium out of the rocks where the canal had been built. And the selenium then got into the wetlands area. The wetlands aquatic ecosystem, the aquatic organisms began to take up the selenium, and then the migratory waterfowl would come in. They go, look at this wonderful wetlands. We'll stop and we'll eat the little fish and eat the little bugs. And so then the birds themselves were taking up the selenium from their food that they were getting out of the wetlands, and it basically had terrible effect on the embryos, and it was basically killing out the whole the whole flock, and it became almost a national emergency, whatever, or certainly a regional emergency, and made a lot of press back then. Now, because I'm a teacher, I've got a homework assignment for you. And for next class, look these things up. In 2017, Flint, Michigan water crisis. Lead in the public water system affected 100,000 people in Flint, Michigan with contaminated water. In 1993, Milwaukee had the cryptosporidium outbreak. It was the largest waterborne disease outbreak in U.S. history, and it affected 400,000 people. 2010, Haiti had that terrible earthquake and hurricane come through, and the rivers there became full of cholera, and the death toll was over 8,000 people, with 665,000 people affected. And in '93, and I would say probably not many folks have heard about this. I actually did a paper on this back then, but World Health Organization intended to do some good things for the folks in the rural citizens in Bangladesh. So they drilled a lot of shallow wells. And so if you remember that aquifer slide where there were the two levels, well, they had drilled into the shallow aquifer. The shallow aquifer had high concentrations of arsenic. And when it was discovered that people were coming down with arsonitosis, and it's sort of a long-term kind of a disease, that they estimated as many as 125 million people were affected in Bangladesh. And anyway, questions? 45 minutes, 47 minutes. Except I started 2 minutes late. Yes, sir.
I have a question. With all these horrible problems you mentioned about trying to reuse water, with all these problems you mentioned,
Yeah.
Okay, with all these problems you mentioned about trying to reuse water, is there any role at all for cistern water for human use like they do in the tropics and in some mountain areas, or is it just not practical? I mean, you could use cistern water like they do to flush, not necessarily potable water, but flushing toilets and taking showers some places.
Well, and that's a great point and a great question. Cistern water is basically rainwater that's been captured, falls on the roof. It'll carry in a lot of dust. Typically, you're not bringing in pathogenic bacteria. You maybe have some surface bacteria. What I always remember was that, at least my mother's generation, they always wanted to use cistern water to wash their hair. And I don't know exactly why. I think it
doesn't have iron in it. It doesn't have all the other things that are regular water.
And I've had, I lived in a house in Southwest Virginia for a while that actually we had cistern water and we had we had public water, and we would drink as much of the cistern water as we could because it tasted better. And we didn't find any, bacteria. The problem, I guess the challenge would be, how do you, and how does it become a reliable source? Because if it doesn't rain and you run through the water, then you got a tank that's empty. And, so there's a lot of challenges.
Probably not going to work in the Mojave Desert, but
right.
Most places have enough rainwater. It depends on how big the collection apparatus is. And, in the tropics, at least, in Hawaii, in the mountains, in the Virgin Islands, in Puerto Rico, they have a lot of cisterns. And if you buy a big cistern and have it, properly covered so animals don't get in, you can get enough water for regular use of a family.
Well, it's a lot safer water than pulling it out of a pond or a creek or a lake, because that's where you've got, full of bacteria, full of contaminants, full of nutrients and toxins.
Thank you for your talk. So, listening to it, obviously there's a lot of ways that people contaminate water that we use that is then going back into the environment and potentially coming back to us. So, do you have practical sort of suggestions on how we can be better water stewards?
Wow, well, that's a fabulous question. And one of the things I didn't say to start was, there's an infinite number of contaminants, there's an infinite number of pathways, and there's an infinite number of consequences. In my field, in the field of sanitary engineering, we have tried to focus on sort of protecting the water supplies, like watershed protection areas, and that gives the water purveyors an opportunity to work with relatively clean water than really dirty water. I'll say EPA has been a great partner I've kind of been in this almost 50 years, and they certainly have been a great partner as have the state health department organizations in whatever state it might be, in encouraging or writing policies that sort of point us in the right direction. Still a lot of work to do. From a conservation perspective, and I guess one of the takeaways I'd like you to think about from this presentation is, we don't really know yet if we're going to be reusing water, how much of the stuff we've really gotten out and how safe it's really going to be. We still have work to do. One of the great challenges of that is the cost. I remember when I was looking at wanting to do some research into these, quote, endocrine disrupting compounds, and I was told by a lab, well, to run one scan is $15,000. I went, whoa, I don't have $15,000. So it's like, it was cost prohibitive probably 15 years ago, 20 years ago. And I think there's been some consolidation as to an understanding, like, well, these things aren't that bad, but like these PFAS, that nobody talked about that 15 years ago. So there are emerging contaminants that we're beginning to recognize. So we got a lot of work to do yet. I will say one thing that's kind of a pet peeve of mine. If you buy bottled water, buy a liter of water or half liter of water, and you bought enough of those to have 1,000 gallons. And then if you bought 1,000 gallons of water out of the DC tap, you're going to pay 10,000 times the cost of the water you get out of the tap to buy those bottles. It's a factor of 10,000 to 1. So anyway, and we're creating all the plastic in the environment, which is terrible. Yes, ma'am.
Hi, that was an excellent talk. I enjoyed it. Don't the Israelis have this all solved?
Who?
The Israelis.
Oh, the Israelis?
They recycle everything. I understand. I've never been there, but I've been reading about it. And it seems that they have a system. They don't have wastewater. All the poop water gets completely clean and they don't say boo. They also have desalination plants, as you would imagine.
They do.
But nothing goes to waste there.
I had an occasion to go up against to propose a competitive technology to the one that Netanyahu has recently adopted a year or two ago. That and a lot of what they do is they'll evaporate the water, so you get very clean water, and then it's condensed, and so you leave the contaminants behind. It's an expensive process, but it works well. Yes, sir.
I think you're suggesting there's continual employment for civil engineers, sanitary engineers. That there's always a balance between how good is good enough for now. And that as we learn more, we find that there are more contaminants, and then we have to decide, is it worth it to deal with that?
And that's a great point, because I think, if I look back in my life, we didn't worry about any of this stuff 50, 60, 70 years ago, but we're still alive. Okay, so we've been drinking crappy water all this time, and we're here. Like I say, I mean, you made a great point. So.
I mean, one of the problems, I have a friend that lives in Flint, and they drink everything out of bottled water. I mean, will take showers out of the tap water, but they cook and drink bottled water. Mm-hmm. And I said, isn't that damaging for development of Flint? And they said, well, the only industry left is the university. It's the only way we can get people to come to Flint. They paid a huge price for what's happened to them. And,
yes, they did.
And it's getting worse.
Well, and we're probably going to be running short. Looks like we got 3 or 4 minutes. My daughter Sherry is helping us on a construction project right now in downtown Alexandria, and it's for the public water company called Virginia American Water, and we're putting a parallel 16-inch water line in to serve an area right through a old community called Del Rey. Maybe some of you know it. Anyway, Del Rey, it's been around for more than 100 years, a lot of those homes. Many of those homes have lead pipes that feed from the water main into the house, and they've been using them. And Sherry's going to be helping Virginia American Water identify which ones are lead so they can replace those. So, those kinds of Flint problems are pervasive throughout the United States.
So doesn't New York City still have wooden pipes?
I believe so.
They may have some of the best water anywhere.
Could be.
Got one more question back here.
So I'm really interested in disaster relief and emergency management, but just coming from a broader scale, in the beginning of your talk, you were talking about how you didn't really see environmental side of One Health being talked about. Is there anything that we can do coming from that human and animal side to kind of create a space for you in, our just create a space for the environment to kind of be more prevalent in these talks and in our collaborations.
Well, thank you. I didn't mean that comment to sound critical, because I think the mission here and everything I've seen has been just excellent so far. I think just recognizing it, maybe, I mean, what would be, I think would be kind or nice would be if more, water engineers and environmental engineers became part of the group. And, that kind of outreach to our organizations and say, hey, we got a One Health program down here. You guys should be sitting in on it and participating. One of the guys that is the regional director of our State Water Control Board in Virginia, I was telling him about this, and he said, man, I'd love to be there for your talk. And I said, I'd love for you to talk. And he said, I would do that. So he would talk from the state regulatory perspective, and he would look forward to that. He wants to kind of coordinate with Blair on that. But I think it's, it's probably more on us, the engineers, to say, hey, look, let's pay attention to this, kind of work together.
Please join me in thank you.
Thank you very much.
And as we like to present to all our speakers, a flag that is flown over the Capitol. Thank you, Dr.
Great.
Rigby, for your time and all your information. We so appreciate it.
Well, thank you so much.
Thank you for your talk. Thank you guys for coming. And I'll just make a fast service announcement for the Smithsonian before you guys head out. They have an event on Monday that I've been asked to advertise, Unsung Heroes of the Microbial World at the Natural History Museum. It's on September 16th, which is Monday, from 6:45 to 8:30, with the program highlighting some of their discoveries that the benefits of microbes have had on the wildlife and how it's changing the way we think about life here on Earth. So if you would like a flyer, please come up. Otherwise, grab some food on the way out. Thank you so much to the One Health Commission and for everyone online. They make it possible for us to have the webinar component. And to ASM, thank you so much for hosting us. And we look forward to seeing you guys next month for a talk from the EPA. Thank you so much. Have a good night. Great job.